Okay, we are on air. Okay, good day to you. Today I'm going to continue with the tutorials for Python programming in the architecture, engineering, and construction industry. So far we have been focused on basically Rhino Common. So this course is actually about Python, but I kind of explained briefly that all the geometric magic comes in this course, at least from the library that we call Rhino Common. Okay, so most of what I'm talking about is sort of focused on Rhino Common and what you can do with it. So, and I sort of said that Rhino script is not something that I'm very interested in, and I'm not going to use it. And Grasshopper kernel, we will use it a little bit today if you want. We will make a data tree in Grasshopper and will we need it? I'm not so sure, but okay, let's create a need for a data tree and make it in Grasshopper within Python, and then we will have covered most of the stuff in this exercise. So far we have generated the voxels and we have colored them according to the distance to an object inside this bounding box, which was a cone, just as an example. It can be any other surface if you want. And we wanted to mark the distances as positive and negative. We wanted to make sign distances, but we didn't manage to do that because we had a bug in our code, right? So we will be looking at this bug and we will try to debug our code. And this experience, we will cherish this experience as a real part of the life, the miserable life of a programmer, right? Debugging code. Okay. So, and sorry for the noises. Our neighbor is not giving up with his renovation. He will be drilling 1,000 holes today. And I cannot mute myself frequently. Okay, so we have seen the creation of these little cubes around the center points of the voxels. And we wanted to also color the cubes as something nice. And I'm sure this nice thing will work during this session. So it's up to you. We can start either with the annoying thing, the debugging, or we can start with a nice thing, which is making nicely colored boxes. Which one?
I say let's go with the hard thing first.
Debugging? Okay.
Yes.
So, okay, let's go through the code. Let's get rid of the annoying thing and then see. Okay, so for debugging, of course, we have to read our code, which is a good a good way to recapitulate what we did the other day. And while we are reading the code, we will read it very critically to see if we have made any mistake here. We must have made a mistake somewhere, right? Otherwise, everything would have been working perfectly. And for your is it? Okay, let me zoom on it in a slightly more systematic way. Okay, so the boxes are there. Let me... Why am I seeing the boxes? Okay, because these two are turned on. Okay, the voxels have been colored and we have managed to create boxes, voxels, and let me take them and take them away. Okay, so everything is normal here, and we want to color these voxels, or the voxels as we call them sometimes, as to the color of the corresponding voxels, which are now represented as points. But this is the nice thing that we will do after we find the little issue with the with the distances not turning into negative distances when we are inside the object. The object has an inside because it's a closed boundary representation. It's a cone that has been capped from the bottom. So we expect it to have an inside and an outside, and we would like to mark the distances of those points or voxel points which are inside the object as negative, and the ones outside as positive distances. Okay, and this is the only part that is not working right now. Okay, let's get to it. So the first thing that is happening is that we are importing Rhino.geometry, and this is exactly the Rhino Common library. Let me open the documentation again. Where is it? Where is the documentation? Open. You see my other pages, right? My screen. You see the Rhino Common page?
Yes.
Opening. Okay, what is Rhino Common? Why did I lose the no, I'm in the wrong place. Oh, wait. API. Rhino Common. Okay, I should put this link somewhere. Maybe I will put it in the chat and you can add it to the repository. Okay. I will still have to give access to you, Anna, to the repository. So this is where we are, rhino.geometry. This little dot takes us into what we call a namespace. A namespace is a collection of tools or methods and objects inside a library of code. Okay. With every dot, we go one level deeper into the library. So rhino.geometry means actually a folder within the whole Rhino command, which is all about geometry, right? So the dot notation actually takes us further deeper inside the library. Okay. Okay. And I'm importing also one standard library of Python inside this component. But again, remember that whatever we are doing here, we are doing inside what is known as Iron Python. It's not real Python. It's something that looks like Python, works pretty much like Python, but it's Python 2.7. It's not the most recent Python 3 point something. It looks like Python and it kind of works like Python for most parts, but it's not real Python. The real Python is something that we use in a different component that is called the CPython component. Okay. Okay, so this is the first, let's say, magical thing that we use from the Rhino geometry library. You might wonder how we are using the Rhino geometry library without calling it. That's because of the type that we have already specified here for this object. We have given it a hint. We have mentioned that this is a boundary representation object. Therefore, we can expect to find a method with this name for a boundary representation within Rhino Common, and therefore we can get the bounding box of the object, and we can then call whatever we need from the Rhino geometry library to give to this method to get the bounding box. If you want to know as an example where to find this method, okay, this was about a brep object. And let me search with Control F bounding box. Not this one. Get bounding box. And this is the version of the method or the function that I'm using right now. I want it to be the bounding box to be aligned with the global coordinate system or the global plane in which everything is located. And this is a different version. This is the exact version of the code or the method that I'm using. Okay. And this is something that I know that I can create a plane like this from Rhino geometry, which has been abbreviated as RG, dot plane, which is a data type, dot world dot xy. This is something that we did. Okay, so far so good. So we have a bounding box, and from the bounding box we can get two important things, which are the minimum corner and the maximum corner of the box, which basically give us 6 numbers in total. The minimum x, minimum y, minimum z, maximum y, maximum x, maximum y, maximum z, right? That's what a bounding box is. There's nothing more to it. It's just 6 numbers, which give us some idea of a box that would be fitting to the object to wrap it as a package. Okay? So, and I did this little test to make sure that what we are looking at is indeed a solid, because a boundary representation can also be a surface. It doesn't necessarily have a volume. So if this method returns a volume, that sort of means that it is a closed boundary representation or a solid, right? And so it has a volume, so it has an interior, therefore I can assume. And I have defined another input, which is for the size of a voxel. And it was convenient to call it a vector, or to take it in as a vector, because I needed 3 numbers. And this is a very convenient way of getting those 3 numbers in without the hassle of taking them separately. But maybe this was unnecessary. I could have taken them separately as well. This wasn't strictly necessary. I mean, I didn't have to create a vector and then unpack the vector here. Okay? This was an old habit. Okay, so then this vector is supposed to take these 3 numbers in for the size of the voxel or the little cubes in the x direction, the y direction, and the z direction. And then we are going to create the center points of the voxels, and we call them points. And then we are going to figure out how many of them we will have in the direction of x, in the direction of y, in the direction of z, and we call them u count, v count, and w count, as is customary in this line of work. Okay. So far so good. Yeah. Okay. And this is a little function that we have written. I close it for now, and we go to the main body of code, which is for voxelization. Voxelization is about creating a regular grid, and for creating a grid, we write something that is known as a nested loop, a loop within a loop within a loop, right? It is kind of like visiting this line in the code, u times v times w times, right? Because the first, what is the first thing, first loop that will be executed? Can you guess? You're muted.
Well, the first loop is the W, then the V, then the U.
Exactly. Because the innermost loop is the innermost scope within the code. Oh, let me see. Let me see. Well, this is the first line that will be executed, right? But for this line to be executed, we will jump into this line, and for this line to be executed, we jump into this line. So, and then for the next line, yes, for the first counter that will be activated will be effectively the counter K, right? Because this loop will be busy with finishing itself, and when this loop is busy, nothing else will work. And then after one time this loop is finished, then we get to this loop, and then we get to this loop. Can you imagine? So the most important tip that I'm going to give you about programming is about this little cursor that is blinking here. This little cursor, yeah? So imagine that you are communicating with a machine that is always waiting for seeing something after the cursor to do something. Okay? So always try to imagine where is the cursor for the machine right now. Actually, the machine will take this cursor from one line to another because of these flow control mechanisms. Without these flow control mechanisms, all algorithms would have been sequences of operations, right? But we call an algorithm because it's a non-trivial sequence, a non-trivial operation in terms of flow control. There is a non-trivial flow, so the flow is interrupted. It's not like up to here we have a sequence. We first execute line 5, then we go to line 6, 7, 8, 9, 10, etc., 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 up to here. Here the flow of the code is interrupted because of a flow control mechanism. What does that mean? It means that for I in the range of U count, which is, I don't know, 10 times or something, we will go through whatever is written within this scope, and we come back here. One more time, we come back here. One more time, we come back here. One more time, we come back here until we're finished, right? And so on and so forth. And when, for instance, we reach this if, we jump into the scope of this if, and we don't get out of it until we're finished. Okay? And I have a feeling that we must have made a mistake here exactly. But let me read through what I've written here. So the voxel creation has gone successfully. So we have created from the minimum corner of the bounding box, which is this smallest point in the bounding box, we are creating some points in a regular grid. We multiply the counter of the loops, the counters of the loops, the 3 nested loops by the sizes of the voxels. So we go steps ahead, regular steps ahead, and as many times as is written in the counter of the loops. Yeah. So this voxel creation has gone successfully. And then if we want, and then we filter out with this conditional statement, we filter out the voxels that are exactly on the edge of the box. I won't go through this because it will take some time and we will lose time, because this one is also working properly. So the next lines which are indented with an extra tab are within the scope of this if, right? So these are the voxels that are being appended to the list of voxels, which are the voxels that we keep, right? So far, everything has been working properly. Then we compute a distance with the closest point on the solid or on the object to the point, to the voxel point that has been created. And we measure the distance from our point to this point, and we call it distance. And here something is not going well, because we never get a negative distance. Because these 3 lines, 48, 49, 50, are supposed to change the sign of the distance from positive to negative if a point happens to be inside the object. But this part is not working. So let me just make a test here and say print something. Or print inside. Let's see if we ever get into this part of the code or not. Well, apparently we never get into this part of this code. Question is why? Is it the tolerance? Maybe the tolerance is too much or too little. Nope. Nothing is happening. Nothing is happening. So we never get into this line of code. That's very strange. Okay, I need your active participation now. So what do you think is the problem?
I'm scared to ask stupid questions.
No. There's no such thing as a stupid question. Please go ahead.
No, but I'm not strong in Python, so that's
Mhm.
why I'm also at the same time trying to understand exactly what you wrote here.
Mhm.
But so you have the several loops in the beginning of this code, and then you
Mhm.
have two conditionals. So if da 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 do something, and then
Mhm.
you have another conditional if, and I don't understand.
Mhm.
Is it something like if something do something or
Mhm.
else do something else, or
That's possible, but it's not necessary to have an else.
so it's if the first one is not working, then the second one is.
Yes, sometimes we do that. If well, the point is that if this is not true, we don't even want the voxel in question. Because if this is not true, that means the voxel is exactly on the edge, so we don't even want it.
Mm-hmm.
So let's see, if I put this line here, let me first show you that something is happening. There are so many of them which are determined to be inside the main bounding box. You see, here I got so many prints.
Yeah.
These are the boxes that we keep.
But so the second, it's specifically the second one which doesn't work.
You see, I now noticed what is the problem. I'm stating the obvious, which is that the closest point on the body of the surface, of course, is not inside the solid. It is on the
Mhm.
solid. So here I should have put points.
Well,
Yes. So, okay.
yeah.
Now everything is working. And I can delete this. Okay. Okay, now it's better. So the colors changed. Why? Because now we have negative colors for those which are inside. Right? The smaller color, the smaller numbers correspond to those which are inside and they're negative, and they're very inside, therefore very negative, very reddish. And the bluish ones are very much outside. So everything is working now. Okay.
Wonderful.
But we kind of got lucky because usually errors are not found so easily. Okay, so if this distance, if this point happens to be inside, then we negate the distance and change the sign to negative. And then one way or another, whether positive or negative, we append them to the list of distances. And then we call some function that we ourselves have written here, which is a function to create a box out of the single voxel. So we have a single voxel. We know exactly that it is aligned with the global coordinate reference system. And we just want to create a little box around it, and we know the size because this is the vector that contains the sizes. And so here we have written this little function that does this exactly. So I subdivide I forgot to bring this little nice hint. Let's include it in the function. So this was our hint as to how we should write this function. We wanted to create this little function that is called create mesh rhino.geometry, which has been abbreviated as RG. We want a mesh object, and I explained very extensively that it's a static method, so we don't have to have a mesh. We are creating a mesh from scratch. Remember, Elnas? Right? We are creating a mesh from scratch, create from a box, and the vertices of this box have to have been given in a very special order, which is written here. And I copied this from the documentation of the code. Okay. So I'm creating exactly 8 vertices, exactly in this order, very carefully with 3 numbers that I'm generating from the voxel size. A half of the voxel size in X, in Y, and Z, right? I'm imagining a center point in the middle, going to the left, to the right, forward, backward, with U, V, and W, left and right with U, back and forth with V, and up and down with W, right? And I'm creating exactly these points exactly with this order. And to my surprise, I did not make any mistake in creating these 8 points, and everything worked just fine for the first time. Usually I make 10 mistakes before I get it right, but when I did this in the previous video, I didn't make any mistakes. So, and this is the number of boxes that we want in every direction, the number of faces that we want on our box in every direction. And again, where did I get this from? From Rhino Common. So it's a mesh box object that I'm creating. So create, where is it? It's going box. Create from box, no. Yeah, create. Construct new mesh from 8 corner points. This is the one. Yeah. And this is where I've copied the shape from. Okay. And why do I put the definition of this function, and this keyword def marks the definition of a function? Why do I put it on top of this code? Because for the first time that I'm going to call it here, you see that the name of the function has been called here. It will complain if I have not introduced it before, right? So it has to be put before this line of code. And this is all there is to defining a function. So we define a name for it. We define 2 input or multiple input arguments. And we have to have a return statement. Otherwise, it will complain very harshly that what do you want me to do? A function is supposed to return something. And again, this keyword return is something that I want you to think of in terms of this very important blinking cursor. It is supposed to return the output of the function exactly where the cursor is blinking. It's not blinking anymore. Exactly when I want it to blink, it doesn't blink anymore, right? Okay, it is supposed to be blinking here, okay? And the term return means return here where I called you and bring it back, okay? Okay, blinking here. Okay, so that's the meaning of return. It will exactly return. Imagine that the cursor will exactly return to this point with the number or the any other output of the function here. Okay, so now I'm going to, what the hell did I do? Did I do something? Syntax error on indent does not match.
Is it with the
Line
tolerance?
40. Did I touch anything in the code?
The only thing I can think of is you changed
Tolerance.
the tolerance several times, yes.
So this is another reason why we should have saved it in our Git folder, because we could have traced the code and we could go back to what was working. When you get it to work, then save it in the Git folder. So, okay. Maybe this is a good thing that we have yet another error. Indent does not match any other indentation level, and it doesn't tell us which line. Line 40. Line 40. Okay, so whatever is happening is happening. Aha.
Or can it be that
Aha.
put
This
the
one.
thing?
It's about indentation, right?
Mm.
Ta-da. Working again. So Python is very sensitive about indentation. These three quotation marks are for marking multi-lines of comment, right? This is not a code, so we don't want it to be executed, so it has to be commented out, right? Therefore, I mark these lines with three little cursors, but when I copied it, I copied 3 extra spaces of 1 tab X too much, and that 1 tab too many space created this indentation error. And you just saw that it could have been a very dangerous error because we didn't see in which line of code. But I guess from line 40, from a complaint about line 40, that it has to be within the scope of this function. So have always a good eye for the scope of things, you know, the concept of the scope of a flow control mechanism. And needless to say, a function is also a flow control mechanism because it talks about certain lines of code which are bundled together and wrapped together as one package, and it's called a function, right? So whatever is happening inside this scope is independent of everything else, right? Unless you have a variable that has been defined outside of this code. You remember the other error that we got the other day? Elnaz, we had defined, while we were writing the function, we had defined a variable outside, which was known within the scope of the function, because this cannot know about something that has been written outside. But the outside world cannot know anything about what has been written inside. So you see, there's a two-way skewed relation between the inside and the outside of the scope. So keep always a good eye on the scope of things, and make sure that you know exactly what you're doing with the scopes with these indentations. Lesson learned, right? So the only reason we are going one tab extra here is that we want to be within the scope of this if, and then we are done with it, and then we go back to the scope of this other if, and then we go back to the scope of the main piece of code, which is here. And this was another function for revamping numbers. Maybe if you are new to Python, this one can also be interesting to you. We just remapped our numbers to the range of minimum and maximum. Any number that we get, we find the minimum and maximum of the numbers within a range. We want to create some numbers between 0 and 1 to use them for making colors.
Can I ask another stupid question?
Sure. You don't have to mark your questions as stupid.
Sorry, but so what you said is these what are they called? Indentations?
Yeah.
They're very important. So it's
Yeah.
not just for organizational purposes, like for your.
No.
So then, can you just scroll a bit more up again
Can
to
I
the?
say something? Some languages actually have other ways of defining the scopes, like putting curly brackets or mustache brackets. Some of them have keywords like next, etc. Python doesn't have any other way of marking a scope other than indentation. Yeah, so it's very, very important that we don't mess it up. Sorry, now?
Yes, can you scroll a bit up back to
yeah.
this if that I was asking? Yeah, so here. So then what
This
actually,
one.
yes, what confused me in the beginning, why I asked the initial question, is exactly that the second if is not placed at the same
At the same level,
yes,
indentation
the
level.
same level as
Yeah.
the first one. So that's why so yeah, so then it's not like a separate sequential operation.
Yeah.
It's within the first one.
Yeah, so that's the whole point. So we should note that this is not a sequence anymore. So in the first few lines, we had a sequence. We do this and it doesn't matter in which order. I mean, I can change the order of these two and nothing breaks, right? 5 and 6 lines, 5 and 6 can be replaced, can be swapped, and nothing will go wrong, right? Because this is a non-trivial, this is a trivial sequence. It doesn't matter which one you do first, right?
Yeah.
So,
Yes, this I understand, but then
but this one is a non-trivial sequence because first we want the point to be acceptable inside the bounding box. So this is the first if. And only if it is acceptable, which is marked at every indentation level that is here, 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 here. Because after this if,
yes,
we are here.
okay.
So all these starting points start with a point that is acceptable within the bounding box. And only then we want to check whether this distance is positive or negative, right?
Yeah.
So first you have to meet the first condition and then the second condition. And what is wrong with doing this the other way around? If I compute the distance first, can you guess what is wrong with that? I mean, is there something terribly wrong with doing this? Swapping the order of these two if conditions.
Well, it will just mess up the test, right? Because you're changing the value to the negative.
Okay, yeah, that's one thing. Maybe it's not impossible to swap the two with a few changes, but it will be a little bit stupid because I will be creating points that I will not use. Because here first I want to make sure that I will be creating distances that I will not use. And imagine if this computation is a bit heavy, if it takes, I don't know, 5 milliseconds to compute, right? You would only want to do it if it makes sense to do it.
Yeah.
Do you see what I mean?
Yes, yes.
Because this potentially takes a long time to compute, right? So we don't want to do it for a point that is not acceptable. So therefore, we only do it inside the scope of this if, right? To save some time. But potentially, this can take. I mean, there's no such thing as instantaneous computation, right? Everything takes a bit of time. And this, my intuition tells me that this is an operation that is not so easy peasy. You know, it takes some considerable amount of time. Finding a closest point and finding the distance to that point. Actually, this one is the most time consuming, most probably. Yeah. And this test actually takes a long time as well. So it makes sense to first filter the ones that we absolutely don't want to save some time later on. Okay. Okay. So, and this was just a linear interpolation with the number minus the minimum number divided by the length of the range, maximum minus minimum, and that remaps our numbers to numbers which will be between 0 and 1. Did we manage to? Yes, we managed to make use of this function, so I will get rid of these lines and hopefully nothing will break. Jesus. Okay, so I just created another problem to be solved. So what is the problem that I just created? Unbound name exception. I'm reading from here. Remaps these is not defined. Okay, okay. And this is not working. So it was working, but I tried to perfect it and then I broke it. Okay, so again, one of those classical mistakes. If it ain't broke, don't mess it up. Uh, so, but it's perfectionism is a part of being a programmer. So we we have to make it beautiful as well. So this is
Remnip numbers.
remap. Ah,
Is that a typo or?
yeah.
Yeah.
It's not so pretty to have this typo here.
Me.
Okay, what is the global name? Ah, this was a global name, you see? This is the problem that I told you about. This used to be, when I wrote it inside another component, and this used to be a global parameter. It's not a global parameter anymore. And I have to change this to
Just to another.
to something that is known within this scope. Okay, remap D is not defined. Do we get a line number 80? Yes.
Yeah.
Okay. Maybe this is a good moment to save the code for making it trackable in Git. So I've been saving different versions of this in Git. And I've been regularly pushing this. Uh, uh, debugged the two first issues. Push. Okay. Do you have a GitHub account, Anna?
I do, yes, but I'm just following you in the course that I'm following from.
Give me your GitHub account and I will add you to this.
Do you need just my email or?
No. Your exact GitHub account.
Okay, let me find it. Okay. Or email, so.
This is you?
Yes.
Okay. So we can deal with this afterwards. Let me see. Okay. Okay, so let's do something exciting, which is coloring the boxes. And like what I did with these two, I will first do it inside the component outside, and then I will wrap a function around it, and then I will bring that function into this piece of code. Okay? So Python. Let's call it a mesh as M. And let's call this C for color. And let's determine the type. Where's mesh? Mesh. And color. You see color? Do you see anything like color?
No.
System.drawing.color. Yes. Okay. Okay, so okay. This is it. Okay, so import Rhino geometry as RG. M dot vertex colors. This is something that I'm doing because I know exactly what I need to do, but otherwise, what would be the way to do this? You have to search for color inside Rhino comment. Shall we do that? Because I don't want to pretend that this is magic, right? So let's do this here. I'm going to pretend that I don't know what I need to do, and I'm going to search here. Okay. Mesh. Okay, so let's go back to mesh. And let's search for color. So this is 1 out of 7. So this doesn't exactly sound like what we need, does it? It talks about the color of the vertices of the mesh.
No.
But we want to color the entire surface of the mesh or the faces of the mesh. So it doesn't exactly sound like what I need, but okay, not so bad. I have something. Color ads. This doesn't sound like it because it says evaluate a mesh normal at a set of barycentric coordinates. Barycentric coordinates. By the way, if you want to know what these barycentric coordinates are or what a mesh is or whatever, let me just give everyone something. 2 introductory pieces from myself about geometry. This one and this one. Yeah, I have 3 presentations with these names that explain all these things in detail. Topology. 1 set of lecture notes. And this is a basic one about the preliminaries of 3D modeling. Okay. Okay. So back to business. Color at. So barycentric coordinates are coordinates of the points inside the faces of a mesh for anybody who listens to this in future. Color at a mesh point. A mesh point is a combination of a face index and barycentric coordinates of vertices inside the mesh faces on the surface of a mesh. What else? Color at, color. Create vertex colors from bitmap. This sounds like it is something related to texturing a mesh. That's not exactly what we need. This is too complicated for what we need. And this is the last one. So I'm going to start with this one, because if you have read the, no, that's not entirely true. I haven't explained it exactly inside my lecture notes, but the colors or other values are usually attributed to the vertices of meshes. Okay, so keep that in mind from me. Colors, numbers like temperature, etc., are usually attributed to the vertices of a mesh. Okay, so if you want to color a mesh, we have to color its vertices. And I know exactly what I need to do, but I'm just pretending that I don't know, and I want to go back to the principles of reading this documentation. So Elnaz, what I'm looking at is what I told you is the first thing is what is it? The first term?
Mesh vertex color list.
Yeah, and as you can see, it's just one single word. It's quite a mouthful, but it's a single word. What do you think is? Yes. What about the output?
The color list, mesh vertex color list.
Yes, and we call this the type of the output, the data type, the data type.
Yes.
So this is a very, very long word, but the whole word together is the data type of what will be returned by this method. Okay. So, and let me tell you something that I didn't explain so far. This is a property. This is not a method. This is not a function, right? From the class or the data type rhino.geometry.mesh, we have a property called vertex colors. This is the name of the property. Okay, let's get comfortable with this terminology here. This is the name of the property. Class is the same, has the same meaning as a data type. This is a property defined on a data type or a class that is called a mesh. And when we get it, we can get a property or set a property. This is the jargon, right? We can either get a property or set a property. When we get it, we are just reading it. When we set it, we write it. Okay? So we're getting it, and what we get in return, this is the data type that has been returned, that will be returned. What we get will have a data type as well, because everything has to have a data type. And it will have a data type called mesh vertex list. So I just clicked on it. Okay, so long story short, I want to move forward. I have searched it up and I've dug very deep in this documentation. I figured out that this method actually does exactly what we need. Create monotone mesh. With one color, create a mesh, right? This is what I'm looking for. Okay, I just, what did I just do? I just executed a command on a mesh, right? How do I get that mesh out? Yeah. So supposedly I've changed something on that mesh. If everything has worked properly, I have changed the color of the mesh. Now what do I do to get it out? I just put it equal to the output of the components. And this is beautiful because I can now bake them with their colors.
Mm.
So what we get is a bunch of colored boxes. They're very, very nice. Let me just cut a piece of this cake for you. Voila.
Mm.
Oh, I had put a copy of the uncolored ones as well, so every one of them is double. But you know what's the problem?
You should, when you create the 3D points and then mesh out of them,
Mm-hmm.
you should turn them off.
Yeah. This is beautiful, isn't it? So the reddest ones are the ones that are the
Negative.
most inside of the cone. Did I show the cone? So now I can bring the cone as well. This is the last created object, very handy. Can check this to wireframe. So this is exactly here. And that's the meaning of what we're doing. Okay.
Mm-hmm.
So, by the way, a piece of advice, I would only work with meshes for creating geometries, for reading geometries, etc. So this is probably the first and the last thing that we do with boundary representations. I mean, I can show you whatever you want to do with, I can show you how to do it, whatever you want to do with surfaces, B-reps, etc. But I won't recommend that you use them. I think you have many more reasons to work only with meshes. Yeah, because they work outside of Rhino and you can more easily find your way with other tools with meshes. Yeah. So you can safely forget that curves and surfaces and boundary representations even exist. If you want my advice. Okay. So now we created this as a little piece of code. It doesn't look like much. Shall I just add them to the same function that we are calling for creating boxes? That's better, huh?
Mm-hmm.
But then the problem will be that I need colors inside this code. And I don't have colors yet. So maybe I can use one more thing from Grasshopper, which is rather useful. And that is the gradient color. So I explained to you in the first session that Grasshopper doesn't have much in its library in terms of code that we actually need, with two exceptions. One that I find very handy is the color gradient. The other one is data trees, if you need data trees, that is. Okay. For those two things, you have to use the Grasshopper SDK, and Grasshopper SDK is Only available if you download it from here. Get SDK documentation. And I have to choose a location for it. Then I have already downloaded it. Oh. Grasshopper get SDK documentation. Just for the sake of this demonstration, I replace it to show you what happens. It downloads the documentation. And opens it. GH. I think it's this one. It's another documentation file. Okay. So let's make another component to convert numbers to colors. I'm going to make exactly this component in Python. Okay. This one. Not because I think this is the best way of doing this, but because I want to use floats for numbers. And this time I'm going to import grasshopper as GH. And I'm going to create, okay, where is the documentation? Okay. So let us guess how we should read this. Again, you have the same idea. You have constructor methods properties, constructors methods properties, and events even. Okay, events are for interactivity. We don't deal with them. Okay, so we want to have a grasshopper gradient component. So how do we make it? So these are constructors. So apparently if we want one, we should construct one, right? So if I want to make one, I should do this, and this doesn't look like a very helpful documentation. What is it? So what do you make of this? This is apparently the name of the data type, right? Do you see anything helpful here? Any keyword that I've talked about today? This is the location of where it is, grasshopper.gui.gradient. Okay.
Okay.
So this is the data type. The question is, where is it? Inside this namespace. A namespace is a location inside a library. So it's like a large library. You have to know where to find something. The meaning of those dots. So with every dot, you go deeper and deeper into a section within a section within a section, right? So this is where you should be looking at. Okay.
Okay.
So I will keep it on the side. So, and it went away. GH dot, what does it say?
GUI.
Exactly, GUI. Let me see. GUI. You see? By the way, notice the little icon of a namespace. Do you see? It's two curly brackets, one after another. This icon is a namespace. This other icon is a method, and properties have a slightly different icon, which looks like a document being opened with a finger. Dot. What was it?
Gradient.
Yes.
Gradient.
That's a namespace again. GH gradient. So we did all this to get to 1, right? And the question is it a method or it's not? A constructor is a method by default. Therefore, we have to open and close parentheses. And I have to assign it to something to make it interesting, to make it workable, right? Okay, now I have to look at how we can. You can add grips to it. You can add color points to it. You can, and you can, okay, now this is an interesting one. So these little icons indicate a method. So sometimes these icons are different from one language to another. Do you remember that we have seen these icons also for Rhino common? Methods
Yes.
are identified with these icons. And what do you guess is the meaning of this little s here? Actually, it gives a hint. Static member.
Yes.
Yeah, you remember?
Yes.
So some methods are static, which means that they don't need an already existing instance of an object to operate on. They can operate from scratch. Okay.
Yes.
And you have to guess what is the name of this color gradient that we are looking at. And my guess is that it looks like heat gradient. Yeah. So, and the question is now, how do we do this? Heat as GH gradient. GH gradient heat. Okay.
And what does it mean, public?
Public means it's accessible everywhere. You know what? Maybe instead of this constructor here, we should do this directly.
Geosheet.
Yes. Yes, they're here. Heat. And then when we do this, it is still of type gradient, and we want to get a color from it, right? So what should we be looking for here?
Get color, render. Yes.
Render background. No, this is about the user interface. We just want to get a color out. We don't want it to render something for us. Read, maybe? No. Add a grip, no. Delete grip region, display. Mouse up, nearest grip, nearest new, normalize grips. On gradient change, read, on selection. Jesus, I don't remember. Linear.
Can we search, for example, by get color or color? Linear, get to.
This is only defining how the colors are interpolated.
Can it maybe explain it within the heat?
No,
No.
nothing. And this is a pretty static documentation. There's no website, nothing. add a glyph. Add a glyph. Maybe you can, one of you or both of you can Google it. Grasshopper, gradient, Python, how to get a color. Grasshopper, Python, how to get a color from the gradient.
Color by value.
By value.
I have a question. How it's not social principles. Using linear or Gaussian interpolation and sampling.
I said
Along
it's true.
it's not the
Okay, I will change the name to relative number. Did it have something like read at? At color at. Okay, let me search grasshopper, Python, gradient. Okay, this is a forum to join if you want to ask questions. It's a good idea to have. Okay, doesn't matter. I don't need to log in. How far fetch is an idea? Okay, where is it? Color by value, did you find a method name like that, Elnas?
color by value. No.
Oh, I also saw it. It's, I think, something else. I'm also on the forum, and there is. I see one answer about linear or cosine interpolation along an input list of colors.
Mm-hmm.
Another one maybe. No, there's some plugins, but I don't think that this is
No.
what we need. But maybe we can do it some other way. Like, does it have to be through?
Grasshopper?
No. We can do it through Grasshopper, but not through this library. What to call it? How to?
Well, actually, it's better not to do it through Grasshopper at all, but I just wanted to use it to show how to use Grasshopper SDK. And apparently the SDK. Color at.
Ah.
It's the British dictation of color.
Ah,
Yes.
it makes problem everywhere.
Yeah.
Okay, yes, now we can convert them to colors. Okay. So I can do this for convenience, but it's a very good idea to create your own components for doing this with colors that you can write with RGB. Sorry, as a little function. So what we are looking for has nothing to do with Grasshopper or Rhino or Python even. What we need is a color interpolator. So Python, where is it? Python. How to write a color interpolator. How to do linear interpolation with colors. This is exactly what we need. So this can be a very interesting, nice assignment to do this in Python, to remove a dependency, basically. Initial color, target color. So this is the start of the range. This is the end of the range. Number of rows. So this is the number of divisions, etc. So this is the task that we are talking about. Okay. So keep this in mind. It would be very nice to do this. And for now, for convenience, I will bring it to. Okay, let's do it like this. Let's write a function out of it so that we can. If each color a point, number, number. For now, we write it with Grasshopper. Some other time we convert it to return. I comment this out. What is it? Okay, everything is working. So I copy this function. Bring it here. And I want to add it to this piece of code. Or I can write another one. Okay, let's define colors as a list for this for mapped distance in
So does it
map
make
distances.
a list of colors like in 3 values in RGB?
Yes.
Oh.
So we are going to do it this way now. I think this is prettier. What was the name? This is a color. Dot append color. Okay. What is the problem with color and string? Because you see, the global name GH is not defined. What's the problem? I've not imported grasshopper as GH. Of course. Okay. And now I can bring the last component here. Or I can have another version of the same function. That's better. A different version of this function that returns a colored box. What is it? Let's call it differently. And now and now oops, no. This is a bad idea. Do you know why? It's a bad idea. Because here I cannot remap the distances. Here I'm creating them one by one. I don't know yet what is the largest, what is the smallest. I have to do it outside of this loop. Can you imagine? So I have to, for coloring them, I have to do it inside another loop after they are. So maybe I can comment this line completely. Okay. I in range of distances, the length of distances okay. I have to bring the point the size vector and a color. What is the color? From the remap distances. Also the ice. And color box equals this. Colored boxes equals an empty list. And color box. Box is not defined. Line 102.
Unbound.
Okay. I have to comment this out. What is it? Vertex colors. 82.
$87.
Yes.
Ah.
This one was American. Okay. So C equals to color boxes. Mesh component here, get them out. Take them. Let's take the last created objects. Everything works perfectly, to my surprise, because usually things go wrong in this way. Okay, perfect. So I save this file, save the code. And I will answer your questions, if any.
I feel like I just need to catch up with the previous one. And then I'm a little bit confused maybe of what exactly what it was. SDK,
SDKs, software development kit. Yeah.
What exactly is that? Is that like a...
Some people call it an API, application programming interface. Some people call it a software development kit. I prefer software development kit for this kind of thing. It's exactly a software development. It's a documentation of the code. So it shows you what is what and where to find it and how to work with the things inside the library.
So it's like a...
Comments, let's say.
So
Comments
it exists within Grasshopper. This library.
No, actually, it's a little booklet that is attached to Grasshopper. It's like the instructions manual for some device.
But it's an instruction manual in order for you to develop
For developers only. Yeah.
It's
For
like
developers who want. Sorry? You were saying something.
It's similar to the Rhino Common
Exactly.
description.
Okay.
Rhino Common
Exactly.
API.
Yeah.
Yes.
Rhino Common is for Rhino, Grasshopper SDK is for Grasshopper. So both of them are documenting the methods, the data types, and the properties for the developers who want to tweak something or add new functionalities or things like that. Yeah.
Okay. So let's say, when you develop plugins, do you use something like that?
Yeah.
Okay.
Yeah. So everything geometric inside my plugins is coming from Rhino Common. And everything with Grasshopper data trees, etc., comes from, of course, Grasshopper data trees, etc.
Okay.
Yeah. Okay, so maybe the subject of data trees has to remain for the next session. What do you say?
Yes.
I wanted to keep these videos up to 1.5 hours, but if you have a question about this one, let me answer it. If not, then we will continue with data trees in the next one.
Okay.
Yes, maybe we can leave it for the next session, but I wanted to ask you, please, I don't know, write down the title of those presentations that were for understanding the concept of you showed in the middle of the...
Okay, so let me...
I can remember the title.
Okay, let's put them here. Preliminaries, 3D modeling. I put them here. Let me bring them. I will bring them here, don't worry.
Okay.
The first one.
I think maybe we can finish the recording and put these things.
Yes. Okay, these will be put in the repository. Have a good day. Stop the recording. Okay.
I was just going to ask also, the recordings of these sessions that you put on YouTube now, are they public right away, or?
They're publicly accessible, but they're unlisted for now. Until you both find the job. After that, find a new job. I mean.
Yeah.
What is it?
So when is this then going to be like every Tuesday and Thursday?
What do you say?
I'm fine with it.
Yeah, we can do it like that. Does that work for you, Elnaz?
Every Tuesday and Thursday? That would be okay.
You're a little bit frozen.
There's one more thing.
Oh.
One more set of lecture notes that I would recommend you to read first, actually. It's really necessary.
Which one?
Rudiments of linear algebra. Oh, I'm not sharing my screen anymore.
No.
Sorry.
No.
This one? Okay. Okay, this one is one of my most popular documents, actually, because it's very general. It's very short, so in a couple of hours you can read it. This is actually an explanation of those lecture notes, the preliminaries of 3D modeling. Which I have to update, so I will appreciate any comment or suggestion for things to be added to.
To be added to what?
To the lecture notes, the slides, whatever.
Okay, sure.
Yeah. Okay, so any other question?
Are you going to make it?
I think I need to study a couple of things.
Go ahead.
Go on, please, Anna. You go on. No, you go ahead.
Okay. I feel like there's a little bit of a delay, so
Yeah.
that's why. But yeah, I was just wondering, are you planning to make this to like a lecture series for everyone in the end? Okay.
But we will make it gradually bigger and bigger. I mean, if you want. I mean, I also invited Basilka and Leticia, but I didn't hear back from them.
Yeah, I mean they're probably with work busier.
Yeah.
At least me.
But it's a part of my initiative for the Open Online University. Elnaz mentioned that she has gotten a scholarship from the She Codes Foundation.
That's wonderful.
So I thought, if they can do this, why can we not do this, you know? So that's why I will make them public at the end.
Okay.
I want to. And also the repository and everything. But I don't know, maybe we can go directly live. I don't know. But otherwise, we can go forward a little and see how it goes. But that's my intention, to eventually put everything online.
Okay.
Any idea, comments?
I have some comments.
Okay, go ahead.
No, but I feel like, of course, this is at all not the most important things. I'm just always thinking about how can it be organized in a more comprehensive way,
Yeah.
etc., etc. So
I need ideas, so please give me ideas. I mean, for the first few sessions, I had something structured in my mind, but from now on, I will need ideas from you.
like ideas for topics, you mean?
Yeah.
Well,
Topics to cover, assignments to do.
and just tell you what I want to know, and then make you things about it.
Yeah.
No, but well, for instance, I would love to have something about the FEM methods and and
Me too.
but
You want to compute finite element analysis results.
finite element modeling, but also discrete element modeling, so that it's more comprehensive. Because, for instance, when I was when you mentioned it during our talks, a lot of times it gets a little bit overwhelming when you don't know. When you don't understand what it is, let's put it that way, at the beginning. So I can imagine that it could be something that, if well structured, could be very beneficial, especially, well, it can be separate, but then something like the comparison of the two and why one is used in one way and the other is used for some other.
Yeah, maybe we can help each other. I mean, I think you have learned more than me in your studies about the two methods.
That is the point. In architecture, we don't learn absolutely anything about these two methods. The time I have ever heard of it.
I'm an enthusiast. Let me put it this way. I have read a lot about the finite element method, and I'm not yet super comfortable with teaching it. But maybe we can struggle together and figure it out. I was actually doing this a long time ago with Sherwin, but he lost his interest in structural design completely. But if you're up to it, I'm definitely willing to do it.
Okay. Yeah, I would be. It would be very interesting for me to learn.
But we can start from something much simpler. And the simpler thing is the force density method for form finding. That is something I can teach very well, very comfortably. Or dynamic relaxation. Have you seen my lecture about dynamic relaxation?
I don't know which one you mean exactly, but I've seen a lot of your.
So dynamic relaxation is a good one. Force density method is something I can do extra. It's very close to discrete element modeling.
Yeah, that would be would be great.
And maybe we should also discuss something modular for the sake of modular design. What do you think, Elnaz? What would work for you?
I think I need to study a couple of things to be more, active in this process. I'm just learning from both of you, and I try to move faster. But I think anything
faster is not that important.
because I need to.
We will be very
because
slow.
I need to study a couple of things
from this point forward. Yeah,
I know.
I think I have to make it. Let me show you something. Just a second.
Okay. Because the whole new idea and methods, Anna, they're all new for me.
Okay.
So
I have to say they're not very old for me either. So don't think that I'm an expert. That's exactly why I'm bringing it up, because I want to be. Oh.
This is made by Anna. This is a piece compatible with Lego for modular
Yeah.
architecture, earth architecture.
Did you take it with you from Delft?
Yes. This is another piece. So we are creating pieces for Lego that do not exist in Lego in ordinary Lego. And this is another piece.
Nice.
Mm.
Yes.
And this is a piece that is invented by myself. This one is a staircase for Lego. This is very important in the modular design for Lego.
Yes.
So we can create this kind of thing. I was hoping to find. Do you remember, Anna, that we had one spiral staircase
Yes, yes.
from Beza's work? I don't find it here. I don't know why.
I can check in Delft if you want, although I don't know if.
No, that room. Okay, I don't find it now. But there. Have you seen Beza's work, Beza's presentation? Elnaz? Beza with Zara Yakub
No, no.
Bekele. So I don't know if I
Is
have
it
it
in
on
your
the
YouTube
website.
channel?
No, it's on the website. So this can be one of the okay, wait. Before I
Integration?
forget, making a spiral staircase is a very good exercise. Let's make a spiral staircase, okay? So as soon as I run out of ideas, let's make a spiral staircase. And then the next version can be making a spiral staircase and making making it as a module for this game, for this
So,
modular design game.
so essentially making a Lego block.
Of course, yes. But a Lego block that doesn't exist. So my idea is to make a pack of Lego only for modular design and 3D print the pieces and
then sell it as a game.
sell it, yes. I didn't want to say that. Yeah. Because the good point is that all the ordinary pieces are available. I buy them secondhand, I collect them, etc. But some pieces do not exist. And my idea is that by only creating a few pieces that do not exist, we can create a perfect set for modular design. And our set can be compatible with the other pieces of Lego. So this is a little secret from my side that I shared with you. So I will be happy to work with you on this. By the way, our pieces actually work together. So they're a bit loose, but
yeah, I think we were trying to establish the perfect dimensions for the 3D printer, and then it was something like, let's say if the actual Lego hole is like 4 millimeters, if you put it in 3D printer, then you have to make it 4
a bit smaller.
2 or something like that, or the other way around. So we were really playing around with these dimensions in hundreds. And so maybe you have some of the test pieces there as well. That's why it doesn't fit that properly. But I think that also the question to kind of ask is what exactly is the goal of it all, and what is the main I guess no, wait. The main topic.
The main goal is getting comfortable with coding in Python for the architecture, engineering, and construction industry.
Okay, so it's solely focused on Python.
Yes.
Okay.
I mean, I can also say something about C#, but I don't think it's necessary. I mean, if you ever want to know something about C#, I've coded thousands of lines of code in C#, so I can help you also with that, but I don't like it that much.
No.
And my bigger goal is to go out of Grasshopper and Rhino and do directly coding in Python inside VS Code. That's why I started with VS Code at the beginning. Because I don't like this dependency on Python, on Rhino and Grasshopper, because it doesn't go well with the idea of open, online, free university. I don't want it to be about something that people have to buy, you know. Imagine in Afghanistan, I don't want to advertise for McNeil to sell licenses in Afghanistan, you know.
Yeah.
That's not my purpose.
Okay.
So, but any other idea is welcome, you know. But maybe finite element is a very good idea, but maybe it's too difficult to.
Okay, maybe at a later time, somewhere along the way.
Yeah, we can move towards it. Yeah.
Okay.
It will be a challenge for me. Yeah. You have to help me, really.
If you assume that I can actually help you with it.
Come on, you have studied the structural engineering, no?
Structural engineering.
Your bachelor's.
Yes.
Yeah.
This is indeed the case.
Yeah. I can borrow you a couple of books and you can read them and.
You know, I actually okay, this is a very weird maybe topic, but it was Orthodox Easter last Sunday.
Yeah.
And it's kind of like a family tradition thing that before Easter you have to do this like deep cleaning of your apartment, which you do once, you know, with all the windows, curtains, and blah 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 blah. So the whole apartment was cleaned naturally. And I found several books that I borrowed from you and never returned. So
I'm
very sorry about that. It was not intentional.
No worries. So maybe we can meet and exchange these books. I have actually put some books for you after I did the same kind of cleaning for our new year.
Okay, great.
Yeah. I have some books for you, and remind me to bring the books.
Yes, it goes both ways. Please remind me to bring the books.
Okay.
Because otherwise they are going to keep standing here.
But what are they, by the way, the books?
So
Do you recall the titles?
So first of all, the Levs one I didn't return. And also the Levs one, you know.
Levs, okay.
Yeah.
Oh, you can keep that one.
Okay. And also I didn't return Optimization for Engineering Design.
Oh yeah. The Levs, the big one. No, maybe I need it for others. But I will give you another one from Levs for yourself.
Okay. And there's another one. It's Optimization for Engineering Design.
Oh yeah.
Okay. So these two.
Thanks for letting me know. Okay,
Yes.
I will give you a couple of books about bricks and stuff.
Yes. That would be great.
But please keep in mind that the next cool assignment that we will do will be a spiral staircase, and after that it will be a spiral staircase inside a masonry module. Yeah. And we will do a couple of Persian arches.
How about how to do without Persian arches? Practically impossible to do without Persian arches. Yes. We start with staircase, then we do the Persian arch, then we do Mukarna construction. We go one by one.
Yeah. By the way, Elnaz, Anna knows about Persian arches and Mukarnas, etc. You know, because her topic was design in Afghanistan. So we have designed Mukarnas together.
Because I have to tell you, even though my topic was related to it, I am pretty confident that all of your students know about Mukarnas, regardless of the topics.
In this year, well, from ERSI, yes, from within ERSI, some of them know, but not everybody got the point. You know why I'm talking about Mukarnas. It's mesmerizing, isn't it?
Mm-hmm.
Yeah. Funny thing is, in Iran, I never liked it because it was representing Oppression. Yes. But here I'm advertising for it.
Yeah.
For different reasons. So it was a long day. So did it go well? Was it easy to follow? If you have any feedback, please let me know. Was it easy to follow, or did it get confusing at the end?
For me, it was confusing because I couldn't, understand the logic of the codings and logics of the
Yeah.
code. For example, in Grasshopper, I can understand the flow of the things, but in this method that you're writing the codes in the inside of this components in Grasshopper, it's not that easy. But I think I need to
Okay.
go through the Rhino commands
Okay.
and all the libraries.
Maybe we can separate a couple of things. It's thanks for the feedback, first of all. I think maybe we can do it this way. I can announce the challenge. We can write the pseudocode together without worrying about where to find stuff. We first figure out the logic of the code, and then we write the code. That must be better, no?
Yes.
For the spiral staircase, let's do it this way.
Okay.
We first assume that everything is possible, then we first write the logic of the code as pseudocode freely, and then we write a list of things to find in the documentation, and then we go about coding it. Because that's exactly how I do it, I don't start just with the code. I start coding on a piece of paper, actually, just thinking freely about how should I do it,
I think it's also about the audience, right? Because are you assuming that the people who are watching this are like they already know Python? Because if so, then yes, it's fine. If not, then I think everything should be explained, very, very like for babies, So when I'm writing this, this does this, and when I'm writing this, it does this. So perhaps can be because I also have other comments, but never mind. Perhaps it can be something like the first lecture where you just show the basic logics of the language itself.
Okay. Yeah, maybe I should have done that, but I just introduced one tutorial, learn X in Y minutes for Python, at the end of the second one, or at the end of the first one, maybe. And I think that one takes care of all those kind of things, Python in general. Because at the end of the day, this is not very much about Python. It's mostly about Rhino Common, and that's...
Yeah, so that's why or it has to be just like either mentioned, or there should be some kind of notion or a link that if you have a language-specific question,
that's a good one.
They will be looked at.
Please ask me while we're recording in the next session.
That, or it can be even just like some link on I don't want to say Wikipedia page, but kind of Wikipedia page with just describe basic operations.
Yeah.
So you don't have to kind of waste time during the lecture.
So how about the following? How about having a session just for Q&A without a recording?
Yes, but also in order to be able to ask the questions, you need to be understanding of what you're asking.
Okay, let me give a better suggestion. So how about you two follow the tutorials in the book Essential Mathematics for Computational Design?
Mathematics.
For the Python part? Please ignore all the other languages. The C# and Visual Basic are useless. So I've wasted enough time on those two. And then you come with questions and we do a Q&A on that.
Yeah, that can be done.
And if you have questions about the questions, we can have an extra session. How about that?
Question. Yeah. Another comment I have also, obviously, like I'm going to drown you with these things.
Okay.
I'm very sorry about that.
No
Again,
worries.
nothing about the not about the content, but more about like the visual organization of it all. The work, this as a workshop format is great. If it's online, I have a feeling that if it is a recording, it is a little bit harder to follow. Just mentally, I don't know how to say it.
Because you think it will be available afterwards, or?
No. The other way around. So if it is a recording, it's harder to follow because things are happening within the workshop. For instance, we were sitting and talking about, oh, where is the bug, or is it in this line or in this line? So there's a lot of these. Let me put it that way. Let's say if a person is talking and they have a lot of the track of thought. So this is kind of the same situation. So I do think that if these, I will say when these things will become the actual courses for the online university, they do have to be edited just in order to make it more comprehensive and easier to follow for the people who are sitting behind the screen and following them.
Noted.
I don't want you to be, I don't know, upset by my comments. I just
No. I understand. You have a point.
The graphics, like even when you use the apps, right? Like the icons change everything. If you see the icon like with a pen, you're like, oh, this is where I press to write. So it's all about the. It is also about the visual. Graphic components.
Clarity.
Yes, for instance, as one of the examples that I like to tell people, I don't know if you're familiar, there is this, oh Jesus, what are they called now? Of course, obviously I forgot. There is this YouTube channel for short documentaries. Explained, it's called. They're called Explained.
Yeah.
They also have them on Netflix, and I think they're absolutely brilliant because the way that they convey information in the visual representation is, I think it's amazing. They draw something little, but you understand everything that they want to say.
Okay. So
nice to.
I remember that you had a very nice presentation for your thesis, so maybe I can ask you to help me with this.
I would love to help you with this.
Yeah?
Yes, of course. This is not the time just saying it just to be like, do it all.
So let me say something. You know a little bit about Markdown, I hope?
About what, sorry?
Markdown.
Markdown?
Yeah.
I don't know anything about Markdown.
Markdown is this way of writing documents on the web. I talk a little about it.
I know, the one that you showed me also with this hashtag header.
And let me show you. Do you see this?
Just a second for now. Yes.
This is an environment for writing Markdown documents in real time.
Yes, you showed it.
This is what you write, and this is what you get. I was writing this for the Open Online University. And it has these nice little icons and everything. So maybe I can invite you to this one.
Yes, that would be great. Will I be able to also add things?
Can you just log in if I send it now?
Yes, I'm logged in.
Can you click on it?
Wait, just a second. Actually, it doesn't show it in GitHub. I think I need to. I think I need to go through my Gmail.
No, just click here in the chat.
Ah, sorry. I thought you meant going to. Clicked, yes. I need to sign in somehow. Let's say with GitHub.
Sorry, it's another one.
Are you sure?
Yes, it's another one. Come to this one.
Sorry. You don't have permission to access this resource.
The second one or the first one?
The second one.
Edit mode. Signed in users. Okay, now do it again.
Let me see. Yes, now I see it. Is there a way that I can like join it so that I don't lose it, or am I already joining it?
Good question.
Let's see. Maybe I can
I see you. I see you.
Yeah, I see you too. Okay, I will put like a bookmark on it. Maybe that.
Can you share your screen?
Yes. Okay. Jesus. Open share tray show. Oh my God, Corona ended. I literally forgot how to show screen. Deny. Yes, it's a little bit of a problem. How do you do this? Show background. I've kept enter for screenshot. Yeah, I have no idea. I have no idea.
It's next to the leaving button.
Show participants, show conversation, raise hand. I don't have it. I just don't have it.
You don't have a share. Okay, let me share and show you what to do.
Oh my God, this is so fun. Wait.
Now, if you press this button.
Wait. It's still loading. Where?
Look, if you press this button. It will show you your so-called workspace. And there you see it if it is pinned.
Okay, let me do that operation. Oh, I'm sorry. This is ridiculous.
Elnas, does it work for you as well? If you press?
I don't have it pinned.
Which?
Oh, I lost you, Anna. The second link. If you press it.
I think I managed to do it.
Yeah?
Do you see my screen?
Yes.
Okay, I found the button. This is what it shows me, so I don't see it actually. I have nothing pinned here.
I only see a beautiful mountain. Nothing.
So it doesn't show my screen. It just shows my.
You didn't share your screen.
It doesn't allow me to share my actual screen. It just shows my desktop.
Anyway, this is
ridiculous.
I'm not sure. Actually, I've been in workshops where the participants are supposed to contribute to writing these notes. It usually takes away a lot of attention from the participants. But on the other hand, it's nice to have it open and you can help each other filling in the workshop notes together. That's my point. That was my point about showing HackMD. So if you want to take notes, you can take the notes using HackMD while I'm talking?
I probably wouldn't try it while we're on a meeting because that would take some time. I'm always kind of writing in my little notebook next to me. That's
that's the thing. I'm also much more comfortable with the pen and paper. And I don't know. I don't have an ideal solution for it, but this is a way.
Okay.
Maybe after the workshop or before the workshop, we can write some notes.
All right.
Yes.
Yeah. Okay. So now I'm almost done for the day. Okay. So was it okay today? And when shall we
Yes.
meet again?
Thank you.
On Tuesday or earlier? Elnaz, you tell me. You have a tight deadline.
My deadline is on the next Friday, but first
Yeah.
I need to plan for what am I going to, present and submit for him. I try to, prepare the wireframe or the pseudocode for this
Yeah.
presentation, and I need to show him that I'm going through learning Python and started to learn Python, and but in parallel way, I think I need to make a more precise image of the I don't know, something like a proposal or the roadmap. I try to prepare it in the coming 2 or 3 days, and then I think at the beginning of the week, your week,
Okay.
or that would be okay.
I can also do it on Monday if that's fine with
Yes.
you.
Let's
Monday?
let's do Monday actually. I have a whole bunch of people coming into the house on Tuesday, so
Okay. So Monday at 6.
Monday at 6, yes.
Okay, I will send you an invitation.
Thank you.
And in the meantime, Elnaz, if there was anything I could help with, please don't hesitate to ask.
Okay, thank you. Okay, sure.
Yeah.
Okay. There you go. You have it. Okay. So shall we call it a day? Yes?
Yes.
Yes.
Okay.
Yes.
Have a nice evening and see you soon.
Yes. Have a nice evening.
Thank you.
Good day. Bye-bye.
Bye.
Bye-bye.